Hi everyone, this is Mrs. GA, and today we're going to be modeling with functions. So when we are doing any type of modeling or word problems, we're always going to use our desk. Here's a quick reminder of what that stands for. First, you're always going to define your variable or variables, and we're going to do this in a very specific way, including units when possible. And then you're going to make your equation or equations, and then you're going to solve, and last, make sure you have a complete answer. Okay, let's try this first one together. A company is designing a box for its product. The box must meet the following proportion. Its width must be 3 times its depth, its height is 5 times its depth, and they want to know for what depth is the volume greater than 60 inches cubed. So in order for us to define our variables, I'm going to look for the question, and they're asking us for what depth is the volume greater than 60 inches cubed. So since they're asking for what depth, that's what I'm going to set my variable as. So I'm going to say x equals the depth in inches. Okay, so here, now we want to see if we can make an equation that models the volume of this box. So we know that the volume of a box can be found by doing depth times width times height. So now we need to find some way to describe all 3 of these in terms of x. So volume equals, well, the depth we already determined is just x. For the width, it says the width is 3 times its depth. So the width is always going to be 3x. And it says the height is 5 times its depth. So we can describe height as 5x. So you can see that now we have a model that describes the volume in terms of the depth. So we have volume equals 15 times x cubed. And now we have to go see how we can use this equation. So they say, for what depth is the volume greater than 60 inches cubed? So we want this volume, so 15x cubed, to be greater than 60. And now we're just going to solve the inequality. So we can divide both sides by 15. So we get x cubed is greater than 4. And from here, we can take the cube root of both sides. X is greater than the cube root of 4. So I'll plug that into our calculator to get a decimal approximation, which is roughly 1.59. And now we need to make sure that we have a complete answer. So they say, for what depth is the volume greater than 60 inches cubed? So we can say the volume is greater than 60 inches cubed when the depth is greater than 1.59 inches. And this is a complete answer. All right, let's try the second one together as well. So this says a gardener has 140 feet of fencing to fence her rectangular garden. So I'll just draw a picture right here. So find the dimensions that maximize the area she can fence. So since it asks to find the dimensions, when we define our variable, it's going to be one of the dimensions. So let's say x equals the length in feet. So let's say this, or you could say that x equals the width. It doesn't matter which one you define it as. So now I look and I see that they want us to maximize the area. So that means we're going to need to find some way to model area in terms of x. So we know that area of a rectangle can be found by doing length times width. Now here, we already see that area or the length can be defined as x. So we can say area equals X, but we need to find some way of describing the width in terms of X as well. So if I had 140 feet of fencing to start with, I've already used up X here and X here, so I'm going to subtract 2X, leaving me with the rest of the fence that I have, which then I need to split up into 2 equal parts. So then I have to divide that by 2. So one way you can describe each individual width would be 70 minus X. So again, I started with the total of 140 feet. I subtracted the fence I've already used, X and X, and then that remaining fence, which would be this expression, you have to divide it up for the 2 widths, so it becomes 70 minus X. So now I can put that into our equation. And now we have a formula that models our area. It's negative x squared plus 70x. So now we can go back and see if we can use this model to help us answer our question. Here they want us to maximize the area, and we know that this is a quadratic equation, so we know to maximize, we're always going to look for a very specific point. We are going to look for the vertex. Now just to give you kind of a visual, again, we have a parabola that is downward facing. And since they actually would like us to say the dimensions that maximize, we're going to be actually looking just for the x value of the vertex, because the y value, of course, would represent the area. And they don't actually ask what is the maximum area. They want the dimensions that maximize it. So we can use our little vertex formula, negative b over 2a, to help us find the x value of our vertex. So negative 70 over negative 2 equals positive 35. So again, let's look at the original question to make sure we have a complete answer. It says find the dimensions that maximize the area. So I see that x is going to be 35, which is the length, but dimensions are length and width. So if you plug in x right here to 70 minus x, you'll see that the width, which again was 70 minus x, is also going to be 35. So our complete answer would be 35 feet by 35 feet. Now, if they had actually asked what is that maximum area, well, of course, you could do 35 times 35 to find it, or that would be the y value of your vertex. So it is really important that you know what they're asking you to find. In this case, again, since they just wanted the dimensions that maximize your area, we wanted just the x value of our vertex. Okay, let's try this last one together. And this says, a hockey team plays in an arena that can hold 15,000 spectators. When the ticket price is set at $14, the average attendance has been 9,500. A market survey suggests that for each dollar the ticket price is lowered, the average attendance will increase by 1,000. So they first ask, what ticket price is so high that no one attends? And then find the price that maximizes the revenue from ticket sales. So since both questions really ask like what ticket price or find the price, when we go to define our variable, we're going to say x equals the price of one ticket. And of course, that's going to be in dollars. So now we need to find a way to model revenue in terms of x, because here they ask for what ticket price is so high that no one attends, which is no revenue, and then they want to know what price maximizes revenue. So we know that revenue in general can be found by the price per ticket, price of your ticket, times the number of attendees. And remember, revenue is different than profit. Revenue is just how much money do you take in before you pay back all of your workers and you pay for the costs of running the game. So it's just price of each ticket times how many tickets you sell, essentially. So let's see if we can describe all of this in terms of X. So I'll say R of X for the revenue in terms of X equals price of ticket. So we already defined that as X. Now we need to find a way to describe the number of attendees in terms of X. So this part's a little bit tricky. So we know that the baseline is 9,500 attendees. And we know that for each dollar we decrease, we would add another 1,000 attendees. So we would add 1,000 attendees times 14 minus X. So this 14 minus X is how much you lowered the price. Right? So if you set the price at $13, you lowered it 14 minus 13, which is $1. If you set the price at $12, you've lowered it $2. So this is really how much you've lowered the price, and that will gain you an extra 1,000 attendees for each dollar. So this is a way to model the number of attendees in terms of X, which is what we want to do. Now we want to combine like terms and multiply this out so we have a quadratic equation. So I'll start by distributing here. So we have 14,000 minus 1,000 X, and I can combine like terms and distribute the X on the outside. What I have left is negative 1,000 X squared. So I multiplied this to this. If you combine these two and multiply by X, you get 23,500 X. So you can see again here that we have a quadratic equation that models the revenue in terms of X, which is the ticket price. So we're going to use this model to help us answer the following two questions. So what ticket price is so high that no one attends? So that means that the revenue is 0. So we essentially set our equation equal to 0, set revenue to 0, and we're going to solve. So for this one, I'm going to start by reducing down my equation a little bit, and I'm going to divide both sides by negative 500, just because I notice all of my terms are divisible by that. So it leaves me with 0 equals 2x squared minus 47x. From here, we can factor out an x, 2x minus 47, and then we can do zero product property, and you get x equals 0 or x equals 23.5. Now, since we have two potential answers here, we have to interpret what's going on. So I say, what ticket price is so high that no one attends? So if I look at the model of this, we get actually something that looks like this, right? Because we have a downward facing parabola. If you look at the original equation, downward facing, and these are my x-intercepts, so it goes like this. And remember, the x axis represents the ticket price, and the y-axis represents the revenue. So you can see, obviously, if I set our ticket price at 0, we're not making any money, so it's 0 revenue. And then as I increase my ticket price, I'm making more revenue, more revenue, more revenue. And then there's a point where our price is a little bit too high, so people don't want to go anymore, so our revenue drops until we've set our ticket price so high that no one attends and our revenue is 0. So between these two potential answers, we want this one. This one represents when our price is too high. So our final answer for A would be $23.50. Now, if you look at what they're asking in Part B, they say find the price that maximizes revenue from ticket sales. So again, let's look at the model that we just drew. Again, we know that anytime you see the word minimum or maximum, we're going to be working with the vertex. So if they say find the price that maximizes the revenue, we know that they're actually asking us to find the x value of the vertex. So B is to find the x value of the vertex. Because again, they want the price that maximizes the revenue. So luckily, you know how to find the x value of the vertex. I'll use the vertex formula, and I'll even go back to our original equation right here. So we can say x equals negative b over 2a. So we can get a decimal approximation for this one. X is going to equal 11.75. Let's make sure we have a complete answer. Remember, they asked us to find the price that maximizes revenue. So the price would be $11.75. So that's the x value that achieves this maximum revenue right here. And you could find the maximum revenue by plugging this in and seeing what the y value of your vertex is. Okay, so that is all for today's video. Thank you so much for watching.